The universe is three-dimensional. Okay. No, the universe is four-dimensional. 3 dimensions for space and 1 for time. Okay, duh, what are you talking about? The universe has 9 dimensions. Okay. Come on, guys. The universe is flat. Wait, what? However strange it may sound, all these statements are kinda true. How come? The theory of general relativity allows for the universe to take one of 3 forms. It can be flat, like a sheet of paper. It can be completely closed, like a sphere. Or it can be shaped like a horse's saddle. It's very important to figure out the shape of the universe. This way, we can learn about its past and future. It can answer crucial questions. Is the universe going to expand forever, or will it eventually collapse? Is it finite or infinite? Here, we need to consider 2 factors: the density of the universe and the rate of its expansion. Now, hear me out. About 68% of the universe is dark energy, 27% is dark matter, and the remainder is normal matter. That's what stars, planets, and our bodies are made of. And when we speak about the universe's density, we mean the amount of matter packed into a given volume of space. And the density of the universe is so great that its gravity is more powerful than the force of its expansion. Then the universe will curl into a sphere. This is what we call the closed model. The coolest thing about such a universe, even though it is finite, it has no bounds. However paradoxical it may sound, if you found yourself in this universe, you would travel its space forever without falling over an edge or hitting a wall. But if the density of the universe was low, it would be unable to stop its expansion. In this case, space will warp in the opposite direction, creating an open universe shaped like a saddle. But the most popular theory, and the most bizarre-sounding one, is that the universe is flat. It might be possible if its density is just right, and it expands in every direction without curving negatively or positively. Scientists claim that it's the most plausible scenario, by the way. So, if you're disappointed by our planet's roundness, the flat universe might come as some consolation. But what does a flat universe mean? I mean, our 3D world seems very real. Can it be just an illusion? Nah. The flatness of the universe isn't that two-dimensional flatness you might be imagining right now. To help you understand this concept better, I'll tell you this. In a flat universe, 2 rockets flying next to each other will always remain parallel. In a closed universe, their paths will diverge, and they will follow the curvature of space and eventually make a loop and meet where they started. And in an open universe, these rockets will separate and never come across each other again. Of course, it'll take a lot of time to prove that the universe is indeed flat. But so far, astronomers don't have even the slightest reason to doubt this theory. All the data they have is consistent with this flatness. For example, the imprints left on galaxies from sound waves that occurred right after the Big Bang also support this theory. In other words, right now, scientists agree that the universe we live in is like a 3-dimensional sheet of paper. Good luck trying to imagine this. But if this idea is wrong and the universe is actually curved, it must be ginormous, because those 93 billion light-years we can observe aren't a large enough portion to let us see even a tiny curvature. So, it might be wrong to say the universe is flat. It's probably better to announce that the little bit of the universe we see is flat. Hey my dear astronomers, last year was awesome. 2 total lunar eclipses, a breathtaking ring of fire solar eclipse, and a rare alignment of Mercury, Venus, Mars, Jupiter, and Saturn. I bet you've been wondering what space wonders this year is going to bring us. Well, let's find out. From April 15th to April 29th, you'll be able to enjoy the LYRID meteor shower. Meteor showers happen when our planet passes through debris left behind by comets and asteroids. That's why such showers normally occur approximately at the same time every year. The LYRID meteor shower is produced by a comet called Thatcher. It takes around 415 years to orbit the Sun. By the way, this meteor shower is one of the oldest. People started watching it in 687 BCE. This year, the peak of the meteor shower will fall on the night of April 22nd, with almost 20 meteors per hour dashing across the dark sky. But if you missed the LYRID meteor shower, don't worry. You can still see AQUARID meteors from April 15th to May 27th. This meteor shower is famous for its fast meteors, leaving long, glowing trails. This shower is produced by the comet Halley, completing its orbit around the Sun every 76 years. Unfortunately, the full moon that will appear on May 5th might outshine most of the meteors, but astronomers promise it'll still be a pretty impressive show. Throughout all of June, Venus and Mars will be on the same astronomical line, looking as if they've been grouped together. And on the first official day of summer, Venus, Mars, and the Moon will form a triangle. You might even see the trio without any special equipment, since they'll be shining extremely brightly. And another meteor shower will start in July and last till September. It's called the Perseid meteor shower, and it's promised to be one of the best of the year. Bright and frequent, these meteors will have long tails and will light up the sky at a rate of 50 to 100 meteors per hour. The shower will peak when Earth moves through the densest region of space debris left behind by the comet Swift-Tuttle. On August 31st, you might notice that the full moon seems to be larger and brighter than usual. This phenomenon is called a supermoon. The moon, which follows an elliptical orbit, will be the closest to Earth. Even better, this year there will be 4 supermoons on July 3rd, August 1st, August 31st, and September 29th. And since there are 2 full moons in August, the second one is called a blue moon. It occurs every 2.5 years. On October 14th, people in the southwestern USA will be able to enjoy an annular solar eclipse. Now, look, solar eclipses happen when the moon passes between Earth and the Sun. But this year, the moon won't cover the Sun completely. That's why a dazzling, glowing circle around the moon will be visible from certain places. This eclipse will be quite short. It'll last for around 5 minutes. On October 28th, we'll also see a lunar eclipse, but partial. The thing is, a total lunar eclipse happens when the Earth's shadow covers the entire surface of the moon. But this time, the moon will pass through our planet's dark shadow only partly. By the way, there's one more type of lunar eclipse called a penumbral. It occurs when Earth's faint outer shadow, called penumbra, obscures the moon. And finally, we'll see another meteor shower from November 19th to December 24th. It's called the Geminid meteor shower. This one is one more fan favorite. Super fast meteors travel at a speed of up to 78,000 miles per hour. Another unique thing about this phenomenon is that the Geminids come not from an icy comet, but from a rocky space body, an asteroid. Astronomers still aren't sure how the asteroid named Phaethon produces meteor showers. There's a theory that it might actually be a comet that once lost its icy shell. Interestingly, Phaethon measures a mere 3 miles across. This is surprising because the amount of debris it leaves behind is truly impressive. Anyway, the peak of this meteor shower is expected on the nights of December 13th and 14th, when stargazers will see up to 120 meteors per hour.
The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light-years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light-years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. One theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow! Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The Moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the Moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the Moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the Moon is shrinking as its insides are cooling. Scientists say that the Moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the Moon. It's shrinking and it's wrinkling. But unlike the grape, the Moon doesn't have flexible skin. Its surface is hard and brittle, so as the Moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the Moon? A recent study claims that it has a tail. And every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium. And our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.